Solid modeling, CE 101. Okay, after the isometric drawing, now it is time to switch to 3D. Because we say isometric is the first step for 3D. Everyone, please take the seat. In this section, you will learn the fundamental concept of producing a 3D drawing. It shows how to create a 3D drawing coordinates, which is called user coordinate system, and how to change viewpoint to see the 3D object. This is what our learning will be. What is user coordinate system? I will explain now. AutoCAD uses two types of coordinates. One is WCS, which is World Coordinate System. This is WCS, and other is UCS, User Coordinate System. What is the difference between the two? World Coordinate System is the standard or the default coordinate system in which you have x, y, z, because we are not talking about 3D, okay? So there will be not 2, 3 axes, x, y, z. Each axis separated by 120 degree, and you have 0, 0, 0. This origin will be fixed at the corner of the screen, okay? Like there you have x, y, similarly. That is world coordinate system. In user coordinate system, you can take this origin to any corner, any part in this screen. For example, your origin is here in WCS, World Coordinate System. You cannot move your origin to here or here, here. Right? Any point here, it will calculate with respect to this origin. x1, y1, x2, y2, x3, y3. But in user coordinate system, the origin can be taken here. So, and you can define your own x, y, z. For example, this direction I say x, this I say y. This as z. You can define your own x, y, z. That is called user. User, you are the user. So you are allowed to create your own working plane. I want this side x, this side z, this any direction you give, it will align x, y, z with respect to that. That is user coordinate system. But it will help you now when doing 3D. So let's keep that in mind. World coordinate system represent the xy plane used as AutoCAD default for 2D drawings. So far, whatever you have done, it is world coordinate system, WCS. Now, user coordinate system are the user-defined coordinate. You, as a user, are defining. They help the user to create his own working plane. I will open AutoCAD and show you how it is. How to create UCS? We have to highlight the UCS toolbar and we can select. It's very easy. Just we will go right-click and we will select UCS. AutoCAD provides 3 methods of creating a 3D drawings. First is wireframe modeling, surface modeling, or solid modeling. For this particular case or our course, we will be using solid modeling. Actually, surface modeling is for water surface, flowing surfaces like oil or liquids that you can see. Now, solid modeling. Solid modeling requires combining or subtracting standard solid objects such as box, cylinder, wedge, cone to create the final 3D solids. So here in the AutoCAD, there are standard objects like box, this type of box, cylinder. What is a cylinder? This is a cylinder, isn't it? Having an axis. Cylinder. Wedges. Wedge is an inclined surface. So cones, etc. I will open AutoCAD and show you that we can use to create any 3D solid. AutoCAD provides 2 tools, solid modeling and solid editing, to create the 3D model. This is a model. Fine. What it is, same like a carpenter. Give a wood. He will make this part, he will make this part like a cylinder, he will cut it, he will take its drill and make the holes, etc. and create this. Isn't it like that? So here in the AutoCAD, we will take a box. This is a box, a rectangular, isn't it? Like a cube. We will take a cylinder, and this is a wedge. Wedge is an inclined surface. So we will take these 3 and combine them together to create a model like this. That's how it will work. So this solid modeling and solid editing command, I think solid modeling command I have loaded as a PDF file on your blackboard. Later on, now if it is not opening, later on you can open and see. Follow the on-screen demonstration carefully for drawing 3D solids. Because today, first time you are practicing, so follow very carefully. When I am drawing, don't try to draw or lose your concentration here and there. Because when I am drawing, you have to see where I am moving my cursor, how I am changing the UCS from one point to another point. That is the only thing where you have to do it very accurately. Be accurate while changing or selecting UCS point. UCS is user coordinate system point. You should have ortho on and you should align x-axis. when we are doing. So when I am doing, you have to follow this. Whether F8, when I am putting on, when I am putting off. Because of that, all your drawing may go out. So this is where, do not draw directly into your A4 size frame. Why? In the exam, normally we give you a A4 size frame. Okay? Then a hard copy of the question, like today I have given you a hard copy. I will give you, for example, the 3D that we will be drawing, a hard copy of it. These are the pictures or the figures that we are going to draw as a 3D. Okay? Take one and just pass it on so that everyone gets it.
Draw the two of them.
Yes. Here and one possible. Just quickly pass one. So here, what I have is, I have two figures here. We will draw, I will demonstrate one, and the second one you will draw and print and show me, and the one on the back is the homework. That for your practice, because you will be prepared. If you practice more, you will be prepared. So there are two objects here, dimensions are given like this. So we are saying, do not draw directly into A4 size frame. Why?
Will go out.
What does it mean by go out? What is A4 size frame? It is a two-dimensional frame, 2D. So you cannot draw a 3D object directly inside a 2D frame. You have to draw it as a 2D, then you have to change it and take it to 3D. So first draw in an open sheet, then align to 2D and transfer to your A4 frame. Then select hidden or legacy hidden in the print preview before printing. When we are printing in 3D, what is our printer? 2D printer. So directly a 3D object it cannot print. Fine? So it will draw certain hidden lines. So we have to select in the print preview legacy hidden so that it will hide the internal lines. What it is, I will show you. Basically, when you are doing before printing, we go to print preview. What you were doing so far? You will select the printer, then you select the limits, then you say center the plot and preview. Isn't it? In that, you have to click something more. What is that? You have to click legacy hidden before printing. If you don't print, select this hidden or legacy hidden correctly, it will not print your object correctly and you may lose the marks. Do the given exercise and practice well. So whatever is this exercise is given, we will practice well. So what is in the 3D? We have to use UCS, user coordinate system. This is the first point should be in your mind. Second thing, when you are using UCS, you have to be very patient and do it carefully with ortho on when you change from one corner to another. That you will follow when I do it. And you will not open AutoCAD A4 frame and draw directly inside it. Why? Because that frame is a 2D frame. It cannot take that 3D object. So this was about this. Of course, we are at the final point part of this syllabus. The semester, you see how fast it finished. So like that, engineering graphic is a tool that you can use in any area of your study, in any different things. So what you have learned is very basics, concepts, or the very important parts of the line drawing, etc. If you keep this in mind and keep practicing, hopefully you can use AutoCAD and drawing tools to draw any type of object. As I told right in the introductory class, first class of the semester itself, don't compare yourself with other. Everyone has a different level of imagination or perception. Some given a problem, few students can draw it in half an hour, another few can take 1 hour also. It doesn't make that because some has given ability of drawing, some people, isn't it? So that is why we always there is a this, but what is important from exam point of view or this, you have to practice because you have to do a certain 2, 3, whatever is the questions given for in the exam within a certain time. So you cannot just waste on your time in doing something and at the end you don't have time for other problems. So practice makes you perfect, you have to keep on practicing. So I hope you have gained the basic and will carry on using it to improve your drawing skill. So is it you have gained something or not? Yes or no? So that's good. I tried my best. Now it is up to you. So please, I wish you all the very best in your future accomplishment. Next week we will be hopefully finished. So keep each other in mind. So we remember and pray for each other's success in this world and hereafter, of course, because it's what the correct concepts should be in our mind. Getting a passing the course or getting something is not should be the aim. You should have a correct set of mind for doing anything. Now, it's not only the A plus or the D plus or this. It is what you learn that you can use it in your life for your own benefit and the benefit of the society, isn't it? So keep this in mind. Inshallah, we will down. I will show you the 3D. You are just giving the clapping, but I see in the morning only 2 students did the evaluation. Why? You don't want to. You see? Because our chairman, every morning he sent a reminder. Please remind your student to do course evaluation. I think they are sending by email or something to a student, but they keep on us banging. Every morning they send us the statistics. How many finished till now? I think in this section only 2 finished. At least till yesterday. Today maybe if you have done someone. So it's not just clapping. If you really like the course you did, you should write some good comments, do something, do it, okay? Or do it now, perhaps. Because some teachers I heard, they make the student do in the class. I don't know whether this is allowed as per the rule or not, which should not be, because it's, anyway, this is what just I would say, today before you go from here, just finish it if you have not done it. Okay, any question about this? Now, you will make more claps when I draw 3D. Why? Because you will see. What will happen? You have seen how good it looks like to our eyes when we draw isometric view just now, isn't it? Now, 3D will look even more attractive. The object itself, because here, as Rakan asked, can I move that object? Here, yes, you can move 3D and you can turn it upside down, anything like a toy, and you can play with it. Okay, so this is the culmination of the course. Basically, all this hard work which you have done will culminate here, and you will enjoy. Oh, this is what I can do when I finish this course. Okay. So now this is isometric. Already we have finished. Now let us open a new drawing, new sheet like this. I opened it, just simply an AutoCAD sheet. Correct? Now, first thing in 3D is we will load certain commands which are not here for drawing 3D. How to load it? You can go from here, top-down draw menu, and you can go to the modeling command and use this. Box, wedge, cone, sphere, cylinder, all this. Or I will go here, right-click, and select modeling. Everyone. Modeling.
On the
You see,
bar or
on the bar, there are. See, what is it? In the side menus, we can turn on and off anytime, because if we load all the menu, the screen will get filled with the menu. It will occupy memory also. So we keep it off. So while we want to use, we will open it. So this is AutoCAD modeling and editing command. Fine. There is one more command that I would like to use, which is UCS. So go down here with the arrow. Okay, can you see UCS? This is UCS, 2 and 1. So UCS, just use this. 2 is more advanced, so UCS. You see, these are the commands of UCS. It has loaded here. So these 2 you have to load. I will close it again. Okay, when you open AutoCAD, it opens a sheet like this. Fine, you have to make sure you are in metric. You know how to make sure? Start up, 1, new. That will give you, this is in metric. Then you go here, right click and select, not mapping, modeling. Modeling and select UCS. UCS will be down, so because ABCD alphabet it will go. Where it is? Here, UCS. So these are the 2 commands. So UCS, I will put it at the side, and these are the commands that we will be using. Okay, this is 3D. Now let me explain what are these commands. The first one, if I take my cursor here and wait, it will tell me what it is. This command will draw polysolid. Create a 3D wall like polysolid. Okay, now this is the box. That's the box that we were drawing just now for isometric, length, breadth, height. So directly a 3-dimensional box it will draw when you select this. Then you have wedge. Wedge is a solid, 3D solid having an inclined surface. This is very important. And one tip which I will give is the inclined surface will take x-axis, the direction. So whichever direction the x-axis is, it will draw the inclined surface in that direction. If you keep this point in mind, when you are drawing, it will help you a lot. Okay, otherwise every time you have to change your, okay, move this, because you have to keep this in mind. Then third is cone. Cone is also a standard 3D figure. If you need, while you are drawing, we will use it. Sphere. This is also a 3-dimensional object. Then we have cylinder. Cylinder is most commonly used with cube because this is a cylinder. When you are making a hole, you will use a cylinder. Okay, so cylinder commonly used in our drawing. And another three-dimensional object is a torus. Torus is like donuts. You know, this is a torus. This is pyramid. It's a three-dimensional standard object, pyramid. And springs. Springs are helix. Springs for any machinery, etc. Now, after this, I will just tell you, because we are doing the basics, you can use another command. This is the union. Union means combine two objects together. You draw one and another. You want to combine, union them together, means add them together. So select the union command, then 1 and 2, then press enter, it will make it as one object. This is called union. Then subtract. The next command is subtract. Subtract means if you draw two objects, 1 and 2, and you want to subtract object 2 from 1, you will select number 1, press enter, then select 2, enter. 2 times you have to. In subtraction, with every click you have to press enter to record. So it will subtract object 2 from 1. It will become like this. It's self-explanatory. You are getting what. Now this is intersect. Means we will take only the common part between the two. Okay, it will take out all other material and it will only keep what is common between the part which intersect. You know, intersection of the lines.
Same as union.
No, not same as union. This is a big difference between union and this. Union is combining two objects as it is. Here, you don't have, you are removing this and this, this and this. How come it is same? This is the union. Let me open. The whole object got combined and become one. There were two objects, two cylinders, or you have two boxes. You combine two boxes as one. Okay? Having this basic idea, we will now draw the 3D. For drawing 3D, this is the UCS. In the explanation on my PowerPoint, I was telling you, I will show how to use UCS. Now, UCS is user-defined coordinate system. Here, X, Y, Z, we can take origin anytime and we can define our own X, Y, Z. How to do it? Let us see. This is UCS. This command word coordinate system. This is previous UCS. All these things we will use. Okay, one by one. And this is the icon which will help you to align once you draw your object in 3D into 2D. So you will click on this to convert your object 3D object into 2D. After that you can copy and take it to your A4 frame. Right? So this one. Now in order to draw, suppose in this given exercise I will draw this. What do you see this object? This is same as what you have drawn as an isometric just now. Except ellipse is not here, in that there was an ellipse. Okay, the same object now we will draw in 3D and see how it look differ in 3D from there. So what I will do, I will take the same base plate. What is the base plate? What is the length, height and depth? So 60 is the depth, 80 is the length and height is 50. So I will select a box. Please follow when I am doing. Don't try to do box. Then it will say specify the first corner. So shall I start here? Shall I click here? No, you have to be rational. Okay, start somewhere in the middle so that you know where you are. Okay, so start over here. Now he say specify the other corner or tell me is it a cube or a length? What is the difference between cube and cuboid in mathematics? Cube. What is a cube?
All all surfaces are
All surfaces are same. It is a 6-sided figure where all the surfaces are same. All sides are same. Whereas cuboid is having different length, breadth and height.
like tissue.
Yes. So you have now what you are going to draw has 80, 60 and 15. So is it all surface same? No, it is L. L means length. So I will give L. Enter. Then it says specify the length. What is the length? 80. Enter. It says specify the width. 60. Enter. Height. Specify the height. 15. Enter. Did you get? Okay. What I draw, I give 3 dimensions. 80, 60 and 15. But what you are seeing just as a rectangle. So why it is not showing it as a 3D? Because still our plane is, you see here x1. We did not change our view to 3D. Now go to view, 3D views, okay, and change it to southeast isometric. You can change to southwest, southeast, northeast, northeast. So this is southeast isometric. Okay, what is southeast, southwest? As you can see, north, south, east, west. This is called southeast, southwest, northeast, northwest. Okay, it means that if I have an object like this, okay, if I am showing in this coordinate, this is southeast, this is southwest, this is northeast, this is northwest. Isn't it? It's just the orientation, how you rotate it. So this is how it is. So your first base is ready. Now here we want to go by 20 and make a cut, correct, as we were drawing. So in order to do that, what I will do, I will bring my UCS, which is here, I mean origin, which is here to here. So what to do? Write UCS, user coordinate system, press enter. Now it is ready. Wherever you want, you can take it. So shall I bring it here, or this corner, or this corner? Wherever I click, the origin will come there. This is the advantage of it. So I will bring it, for example, here. Then whichever direction I took as the first direction, it will align x-axis in that direction. If I want this direction, x-axis will go in this direction. If I want this, you see he's moving x. If I want this direction, x will go this direction. So you have to define x-axis first, then press enter. See, x, y, z. Fine. So if you define x-axis, y and z automatically get fixed. How?
Common. Constant.
Yeah. Because if you fix one axis, the other are 120 degree to each other.
Yes.
So every 120 degree, it will draw the next axis. So it means that. Now, there is one advantage, again in AutoCAD, you can fix one axis and rotate the other two. You have three axes, 1, 2, 3, like this. I can hold this and this two I can rotate. I can hold this and this two. How? This is the way. This command will tell you rotate along x-axis. Rotate the user coordinate system along x-axis. Okay. See, what will happen when I click this, x-axis remain in the same direction, y and z will change. You see, I am clicking here, then press enter. Did you see what happened? Now again, one more time, rotate along x-axis, press enter. Rotate along x-axis, press enter. Every time y and z is changing the direction, do you see? X remains the same. In the same way, I can rotate along y-axis. Rotate along y-axis. Press enter. See, y-axis remains same, z and x changes. Following? Now rotate along z-axis, press enter. Z remains the same, it changes, the other two changes. So that is it. So I will say, and if I want to send this UCS back to its original position, I will say UCS, enter, enter twice. Just on the key, 2 times, it goes back. So simple. But how to move and this, if you are following these points correctly, 3D drawing will be very easy, it won't be difficult. Any question? How we are moving UCS and how we are aligning X, Y, Z? Yes, gentlemen, on the back. You are following this? Yes, Mustafa. What is it? Then why? I am saying yes, tell me, and then nothing. What you did not follow? Just tell me, because next week you have to show it. UCS is user coordinate system. You can take your X, Y, Z axis in any direction and you can put it, I want X in this, Y in this, Z in this direction. Okay? In the rectangular or WCS, you cannot change X, always X here, Z here, Y here. You cannot say, I want X here, Y here. No, it will go by a standard. Why? Without UCS allows it. That is only the difference. So we are just writing the command, or you can select from here UCS, this one, and then you can say, bring UCS here. And I want x-axis in this direction. So just go and click there, then press enter. Khalas, x-axis in that direction. Whichever. Okay? Like that. UCS, press enter. So this is where I have brought it. Now, I have to move by how much? By 20. In which direction? In the direction of x. So what I will say, UCS, press enter, and for new, then I will give this 0, 0, 0. So x-axis 20, 0, 0. It means I want to move along x-axis by 20 unit and y and z as 0. See what happened? The UCS moved from here to here by 20. Why? Because I give y and z as 0, x move. If you want to move y, you will give 0, 20, 0. It will move in y direction. If you want to move in z direction, 0, 0, 10, not 0, 0, 20. Or if you want two direction to move, give 10, 15, 0. So 10x, 15y, 0, z. So it will move like that. Coordinate. X, Y, Z. Now what? I will choose a box here, which is a box because I want to cut. So when I am trying to select this point, what is happening? It is going to the center. Center is the midpoint, isn't it? So when I click, it will go there. So in order to avoid that, what you can go to the object snap setting and put the midpoint off. Fine? That's one way. Other way, you can select in other. Now when I am trying, it is going here. So if you are confused with that, just release F3, which is F3 is object is snap command, select this command, and then what you will do, you will draw the box, cube or length, L. Now, what is along x-axis? What is there in along x-axis? How much it is? 20. What is along y-axis? This y-axis in this direction. So how much? 1, 5. Now, what is along z direction?
20.
Just move the cursor where you want to draw. It will draw in that direction. Now, when I draw it, I will show you, purposely we were doing like this. You see, when I am zooming, it is the two lines are not coinciding. Can you see here? So, when this happens, when you do addition or subtraction, there is a difference. It will not do addition or subtraction. Okay? So, you have to be careful. This is where I was telling you that accuracy is what is important. You have to take it. It means when I am drawing this, it was wrong. So, I will delete it. But I will draw it again. Just zoom it or wherever. See, what will happen when you try to zoom in and out very fast, it will change the coordinate system. Because for you, it is simple zooming. But for the computer, it has to calculate all the coordinate with respect to the scaling. Actually, zoom in, zoom out is scaling. You are doing 1:2 or 2:1, something like this, isn't it? Either it is compressing or enlarging. So in the background, it has to calculate all the coordinates. So if the memory doesn't support or RAM, it will check. So do it very carefully. Don't do it fast, it may stop, especially for some computers. So select the box, select the point, then cube or length, L, then go in this direction. What is this? How much is X? 20. How much is Y in this direction? 20. And Z, are we going up or down?
Down.
Down. So force your cursor down so that it will understand we have to draw down. Okay, X, Y, Z. Fine. Now, we have to draw a circle here. What is that circle? It is a cylinder because it is a three-dimensional object. There is no more circle here. So I will take a cylinder and midpoint of that cylinder will be your center. So go here, object is now settings, check the midpoint of that line. Okay. Now select this cylinder. Go to the midpoint. This is the midpoint. Then draw the cylinder. How much is the radius?
Until it
10.
touches
10. And then Z direction, it will take the 10. So
15.
I want it down. If I press like this, it will draw it up.
15. Down.
So go down and draw 1, 5. Okay. Now, this object we have drawn, we are working on the bottom plate, isn't it? Now, say union between this object and this object. Press enter. Now cut it. So say subtract. When you want to cut something, you are subtracting. Subtracting from larger object, press enter. This is important. If you don't press enter, it cannot do. Press enter, then select the second object, press enter. See, it has cut it. Now, if I say UCS, enter, enter, it go back, your bottom plate is ready. Isn't it?
What if I choose the smaller one before the
It will not, because software will learn. You cannot subtract, say 5 from 2. You can subtract 2 from 5. From larger number, a smaller number. But from a smaller number, same thing like that.
Yeah.
Okay, so it is like practicals. You don't have negative things over here. So always select the bigger one first, press enter, then select the second one. Now, what we have to do, now we will draw the other object. So for drawing the other side, what I will do is, I will take a cylinder, okay, and cut. Before taking it, let's move the UCS here. UCS, enter, bring it here. And take the x-axis in this direction, enter. Okay, now take a cylinder, box, take it here. Then cube or length, L, enter. What is in x direction? How much it is? 30. Wait, what? How? What is that? 30 is how? It's given there, 30 dimensions. So I will take a cylinder or a box, sorry, and in this direction, cube or length, L, enter. Then it will ask, what is the length? So in this direction, how much it is? 30. Then press enter. Then in this direction, how much?
20.
20. Enter. Then shall I go down?
Up.
Up. How much?
25.
Very good. 25. Enter. Yes. Now, what left? There is an inclined surface. So, inclined surface is the wedge.
Along X.
So, I will say UCS, press enter, I will bring it here. I will bring the UCS here for convenience. Convenience means while drawing, you will be knowing where you are. So, this is the UCS and X in this direction. Y X in this direction is where the slope is. So, I will take a wedge, go over here, cube or L length, enter. What is in the X direction, how much? 30. In this direction, it's moving that side, you see? So even if I am moving my cursor, it is going that side. So if this is happening, it is being, the links are not getting formed, just instead of giving 20, give minus 20.
Use F5.
Minus 20, enter. There is no F5, this is not isometric. Then what is the height? 25. Tell us. Join them. You will union them together. So where is it? Union. Take this object, select second object, third object. All three you can select together, then press enter. Correct. It is now a three-dimensional object. Now, how to do? UCS, enter, it will go back. Now, still I see there are some internal lines, isn't it? So, just in order to view the, say height, this is height. Now, what remains is there is a hole to be drawn. What is this zigzag line? I will tell you. One minute. Now, we want a hole here. What is the center of the hole? We need a diagonal to locate the center, isn't it? So, just draw a line from here to here. Now, midpoint of this line is the center. Now, how you do the hole in 3D? By selecting a cylinder and cutting. Okay, cutting means subtraction. So, select a cylinder, just go to the midpoint. Okay, what is the radius? 10. Okay, enter. Then, like this? No, go in this direction. How much? 20. Enter. Correct. I did it. Now we have to do subtract. No, subtract, because you are cutting something, taking out the portion. So you will subtract. Whenever you want to make a hole, it means you are taking out the material, like drilling. So you will do the subtract. First this larger object, from there subtract the smaller object. Then view height. Okay, because this is a construction line, we draw it to locate the center. This is the box. So the same object, what is the difference between 3D and isometric is, because you will be using a 2D printer to print it, it will always give a zigzag pattern, some sort of lines, wherever you cut. Now, without this, if your printout comes, it is not considered as a 3D drawing. You may not get the marks. In 3D, you get the marks or you don't get. Right? So make sure in your preview that this is there when you print. Although on your screen it may show, but it may not print. Why? Because you did not select that legacy hidden before printing. Okay? In the exam, students wait till the last moment. When the time finished, they want to print and they forget. So whatever 1 hour, half an hour they work, actually it is zero here, because in the printout, if it is not a 3D object, it cannot be considered what you have drawn, because this can be an isometric drawing also. So that is the difference between them. Now, before I ask you questions on this, I will show you something that we can rotate this object. Then I will show you how to print it. Okay, print. For example, this has been now drawn as a 3D because you have 3 axes. The first thing you should do is convert it into 2D. Okay, how to convert? Go here, align the plane of the user coordinate system with respect to this screen. So what it will do, it will keep X and Y axis and Z axis, it will make perpendicular to this screen. It will go inside. So when I click, what happened? It become X and Y. Now this object is ready to be copied and pasted into your A4 frame. Without clicking this, if you try to take and do anything, it will not print. Okay, it will become flat on your A4 frame. Okay, one more try. Okay, I will say undo. This is a 3-dimensional object because you are seeing X, Y, Z as the 3 axes. Right? Now, 3-dimensional object, if I copy and take to my A4 frame, my A4 frame is a 2D frame. So it cannot accommodate these 3 dimensions. So first we have to convert whatever drawing we draw, this figure, anything you draw, after you finish and you say view height and you are sure that this is being shown. Then you are completed your drawing, now you are ready to take it to your A4 size frame. Then at that time, just go here to the UCS and say align to XY plane. View align to XY plane. Then when I click this, what it will do, it will change the axis to X and Y. Figure remains the same, but it will align Z perpendicular. So it's ready. Now you can just copy this object. Okay, control copy. Then you can open a A4 size frame. For example, this is a frame. Isn't it? Just I open from my sheet any A4 size frame, and I will bring here and say Control V, paste. We have pasted. Okay. Now after pasting, again I am seeing the lines. There is no zigzag pattern, etc. Now how to go? Control P. You have pasted. You write your name, ID. This is a regular process. After that, select the printer. Okay. Then go, of course, limit, center the plot, preview. This is what it will print. Is it a 3D?
No.
So you will not get the print. Why? Just go back. Because you have to select here as hidden, legacy hidden. Just select this legacy hidden and then check your preview. How much is the difference between the first and this? Just because of checking that hidden. Hidden means all the hidden line, it will take it out, and wherever you have a cut portion, it will give some sort of pattern to it to show that this is the area where he cut the object. So this is now, I say print, it will print exactly as you are seeing. Because now what you are seeing is what printer is understanding this drawing. Your name, ID, of course, will be there, and this is the printer.
What was the thickness of the zigzag on this one?
There is nothing. It will do automatically. This is by default. Okay, sometimes this is closed. Now, student will start, oh, wait, where is it? Where to select the hidden? You see, this was closed. So, you have to open it and check over here. Fine. Everyone followed this, because these are the common mistakes from previous semesters. And in the exam, we don't tell what it is. If you are stuck, it is up to you. So it's not why we are telling, because if you are only 1 week away, so you should not take it like something done 1 month before, I forget. No, all these things you should keep. Fine. How to select here? Any other question? Now, legacy hidden, we have selected, then check your preview. Now say print, exactly like this, it will print. Okay, sir. This is one thing. I brought it to the A4 size frame. Now I will go back to my drawing, which is this. From here, I copy and go over there. Now I will show something interesting. This is the drawing that you have drawn. It's a line drawing now. How to see it as a 3D? View, hide. Hide means hide the internal lines. So this is a 3D. Can't you see it as a 3D? Yes. Now, one question he was asking, when we draw isometric, can we rotate it? We cannot rotate isometric, but this is a solid object for the computer. You can rotate as you like. For example, I will go and select one command, orbit. This O-R-B-I-T, orbit. Orbit means rotate. So this command he has loaded here. Can you see this? This. So this is free orbit. This is continuous orbit. So if I select free orbit, I can rotate like this. I can see it. How you, whichever direction you want to rotate it. I want to rotate it in this direction, okay? Like this. If I select continuous orbit, then see what will happen. Just I give a hint, it will start rotating. Which direction you want, you can stop and say, okay, rotate in this direction. You will say, okay, rotate in this direction, rotate in this direction, whichever you like. Now, after that, you want to stop it. So say view, 3D, and southeast isometric. So you have gone back to its origin. Now one more. Wait. There are very interesting things now. View. You can say visual style. Visual style, you can make it like a realistic. How a real object look like, or a conceptual. If you have a 3D printer, it will give you like this. Exactly. Print or make a model like this. You can give color to it. Green color here, red here, blue here, whichever. These are all editing. Just right click, go. Okay, this surface, make it red color, this green, this circle, this. So the more time you spend, the more beautiful you can make it. Now, let us rotate and see how it will look like. It's like a, what? Screensavers and this. So you can produce anything, and you can, okay, you don't like this, so change the movement. I want you to move in this direction, in this direction, in this direction, whichever. This is the beauty of 3D. See? Now I am sure that after this you will love doing more drawings. Because now what you are learning, for example, in the beginning, when you start in English, they say this is noun, this is verb, this is pronoun, this is this. Now, when you write a sentence, do you think of a verb, noun, all those? Like, so what you have learned, auxiliary view, orthographic, these are basic grammars of a engineering drawing. Now, you know the language, communication language. So everything is 3D nowadays. That's what we are doing. If you are using AutoCAD 2010 to 16 or 13 version, you will find that each new version has something more about 3D. All other things remain the same. Fine, whether you do it in 2007 version or 10 or this. But the newer version will have more and more features of 3D because the world is 3D. That's why in the introductory course, I told you that even Boeing 747, they have 100% design and they check like this. They make the trials, everything on the screen. What will happen when we make a fast turn? What will happen when it goes down? What will happen? Everything it gives. And they check where is the forces. Where the force is more, okay, this we have to control. When it is going down, we have to put a plate here so that it will come. Like that. They have designed everything like this. No need of going out and making a model and checking in the field. It's sitting on the lab, in the computer with the lab, you can do all the simulations and you can see what will happen if the wind comes with a great force and hit it. They will create this scenario and they will see and adjust what is required. Like that, now I was telling you exactly. Same thing about cars. You see new models coming, very sophisticated model. This is because all these simulations over there. Similarly apply to industrial object or any building, anything. So this is why this is the most interesting and especially for those who has interest in graphics over there. Now this is one object. You can design any other objects. Now I will stop it. I will go back to my original view, 3D, isometric southeast. This is my original view. Okay, now you want to go back to original, what you have drawn, then just say view, not view, render to. Okay, render is also an interesting thing. What is happening now? The Autodesk special features have not been installed. Otherwise, if I go render, I can give different colors, lightening to it. So while it is rotating, it will give red color here, blinking green here, like this. So it will become like a toy, playing toy, pop. Because maybe for memory they have not installed the library. He say install the medium image library. So I don't have a CD, so I will not, I'll say cancel. So shading, you can do shading. Oh, he will give you an idea. He's trying to render something to give you an idea what it is. So see, so this is the amazing work that 3D can do. Now, having the basic knowledge of the graphics, lines, etc., ultimate things are 3D. But if you don't understand that things properly, then you may miss here. That's why first we teach all the basics of engineering graphic language, then in the last 2 classes of the semester, we teach 3D. Now 3D, you can play with it. You can go, if you have interest, now itself you will sit and draw 2, 3 objects. You will take this object. How you will draw? You will take one box. This is a cylinder, this is a wedge. You need 3 things now. Box, cylinder and wedge. Because hole is a cylinder. Just take a cylinder of this height, take a box, combine them together. Draw a wedge, combine them together. Take the cylinder, make a hole. Subtract. Khalas, this model is ready. Start to rotate. In 5 minutes, 10 minutes, maximum 1 drawing. You are ready. So this is what the objective is. Because this is part of our syllabus, this you have to know over there. Again, the printing is only thing when you go control print, select legacy before printing. Any question? Isn't it? Now, I hope everyone has really enjoyed this semester, and what is the culmination? Important is last part, the how you climax of it. Okay. So just draw, at least for your purpose, this drawing. Okay, and rotate and play with it.